Okay, question 5 of the Edexcel Sample Assessment Materials Paper 1 at GCSE 9 to 1. We are coming to a kind of quite a calculation-based question. So a car accelerates at a constant rate of 1.83 metres per second squared, that's an acceleration, along a flat straight road. The force acting on the car is 1.870 kilonewtons. Be careful of the kilo there. And this is a force. Calculate the mass of the car. Give your answer to 3 sig fig. So if I've got F and A and I want to know M, I'm going to use Newton's second law, the famous F equals ma. Rearrange, M equals F over A. F is 1.870 kilo. So I'm going to write times 10 to the 3. Or I could just write times 1,000. 10 to the 3 means 1,000. Divided by acceleration, which is 1.83. And the answer there comes out as 1021.9 kilograms. But they want it to 3 sig figs, which is 1, 2, 3. Think about, do I need to round that to? No, so it's 1020 kilograms that you're writing. You can't just stop it, you need to put the 0 there as a placeholder. The car accelerates from rest for 16 seconds. That's going to be a time. Calculate the speed of the car, which is going to be v, after 16 seconds. So I've got an acceleration, I've got a v, I've got a t. Another equation I need to remember is the definition of acceleration. Acceleration is change in speed, final speed minus initial speed divided by time. Now it says the car accelerates from rest, so the initial speed u equals 0. So I'm going to put the numbers in here, and usually I'm going to put them in before I rearrange here. So acceleration is 1.83 equals v that I'm looking for minus the initial speed 0 divided by the time, which is 16 seconds. So that means that v equals 1.83 times 16, or v comes out as 29.3 meters per second. So if you know these equations, it's really easy marks. If you don't know the equations, you're missing out on a lot of marks there. So it's a good instance of showing where you need to know those equations. Part C, the car starts on another journey. Figure 6 shows a graph of the car's movement. Show that the distance travelled when the car is moving at a constant speed is greater than the distance travelled when the car is slowing down. So this is a velocity time graph. Therefore, the constant speed section is from A to B. A flat straight line like this, a horizontal straight line, is constant speed. It's travelling at 16 metres per second. Here it's speeding up, it's accelerating. Here it's speeding up again, just not accelerating at a constant rate. And then C to D is slow down. So the slowing down section is C to D. And for a velocity time graph, the distance travelled is the area under the graph. So for A to B, I care about this area here. So the area here is equal to the base times the height, because it's a rectangle, which the base is 15, the height is 16, and 15 times 16 comes out as 240 metres. For the slowing down section, which is here, be careful with this one, the time, it's this area here, and it's a triangle, so the area equals 1/2 times base times height. The base is 9, it's 41 to 50, and the height, this is a funny scale, it's halfway between 28 and 32, and halfway between 28 and 32 is 30. Be careful, I made a mistake there before. So 1/2 times 9 times 30 is 135 metres. And 135 metres is less than 240 metres, as shown in the question.